welcome everyone. Today we're having Aaron, Fritsch, and Elisa Logic, and I will let them do their own, which they will do a much better job than I would. So with that said, the floor is yours, guys.
Thanks, Ellen.
Thank you. And we really appreciate the invite to come speak at Speckle. And just to say, super proud of you guys and everybody that's working with you for the work that you're doing. It's super important in the industry, and it's sort of like an evolving conversation that I'm happy to see continue to evolve and to be, somewhat peripherally a part of. So I'll just start by introducing myself. I'm Aaron Fritsch. I'm the head of growth at Archilogic. Just a quick thing on my background, I suppose. I used to build systems related to space for Apple retail, real estate, and development, where I was introduced to BIM. And that's also where I was introduced to the complexity of BIM, I suppose. And then I went to go do what I was doing at Apple for lots of companies as a consultant at Case. And that's where I met Matteo. And then as I think the industry knows, Case was acquired by WeWork. And at WeWork, I ran the team that built all of the internal systems for finding, building, and maintaining WeWork's portfolio of spaces. And in 2019, I joined Archilogic because Archilogic is the product that, had it existed in 2015, I would have bought it off the shelf and implemented it to do what we were doing at WeWork. And I'll hand it to Elisa to introduce herself.
Hi, everyone. My name is Elisa. I'm the head of product here at Archilogic. I spent my first half of my career practicing as an architect in New York City. I've worked across different sectors in education, healthcare, and residential. And most recently, before I joined Archilogic, was commercial real estate, specifically an office at Notel, which is a flexible workplace provider. I worked as a senior product manager at Notel, mainly focused on building internal digital tools that helps optimize the entire life cycle from sales design to build and operates the spaces for about like 200 plus locations worldwide when I was there. And that's also where I met Archilogic and used Archilogic platform as a client.
Okay, so Elisa is going to take on the beginning of this presentation, but just to kick off on the main idea here, this is all about the idea of meeting people where they are and how we think about building information both inside and specifically outside of architecture, engineering, and construction. Let's see.
Cool. So for today's, great, thanks. For today's talk, our agenda for the first half, we will explain how the idea of meeting people where they are, its approach to structuring our information and make it accessible for both industry professionals and outside stakeholders. The second part, it will be demonstrating how innovations is being unlocked outside the AEC industry, and just by giving outside stakeholders access to this abstracted building information. And at last, we'll do a live demos on our editor and our space API and how we use that to run a space test assertions prototype. So 1 second. So traditionally, technology are designed by and built to improve and streamline workflow within the AEC industry. AEC folks have control over the conversation because the life cycle of a building often start with design and constructions. So as a result of this downstream effect, the expectation is that everyone should speak the AEC language, regardless if you are in real estate owners, operator, or tenants. Making data accessible, it is assumed that the data should really still primarily cater to design and construction professionals. And this often make it quite difficult to answer just a simple questions from an end user perspective, such as so who's the manufacturer of the door? I just want to order the appropriate hardware for a replacement, for example. So if you are already operationalized with BIM, sometimes you would run into an issue about like how, let's say, Forge is not syncing with Beam 360 properly, and therefore like I can't really get that information for you. Another pain point I personally experience is that implementing BIM outside of the AEC industry is really difficult. So when I was at Notel, we expanded from 20 locations in New York City to 200 worldwide in just 1 year. In addition to coordinating with our AEC partners, the architecture team would spend like half of their time just answering questions from internal sales and operation team, like, hey, what's the square footage of like, this area of the floor plan? Or like, hey, can you update this floor plans to like fit 20 desks instead of the 10 desks showing here? So to solve that, when I was at Notel, like I then spent over a year trying to convince the management team to implement BIM for operations across the entire company. But it just didn't go anywhere because it was extremely expensive and labor intensive to do so. To be very clear, we really think making data accessible and open source within the industry is a big challenge of its own, given the data complexity from different work streams across architects, designers, engineers, consultants, and contractors. But we also know that there are folks outside of the AEC industry need easy access to the building data for their day-to-day work. So people who work in different part of the real estate lifecycle, for example, like marketing, portfolio planning, and operations, need access to different building information to help make better decisions about their spaces. So at Archilogic, our core focus is making that information about interior space accessible to people outside of the industry. So to achieve this, we take an approach of meeting people where they are. And we believe by converting and surfacing just the right information at the right time will help people better understand and utilize their physical spaces. So I'm now going to head over to Aaron, who will walk you through how we approach this, how we apply this principle throughout our product and services.
Okay, and I apologize. I can't keep the screen in full screen for me to run through the presentation from here. I have to jump back and forth between various tabs. So I'm trying to, I probably should have had multiple windows up here. I'm trying to see the chat screen and people's faces and yeah, and the presentation.
Also, maybe I can share my screen.
That's okay. I got you. It's all good.
Okay.
So the idea here isn't new. So if you think about the world of geographic space or web mapping systems, this problem was solved 16, 17 years ago. So what Google Maps realized is that cartographers and topographers, people who generate and create information about geographic space, they're really important. We need them. We need them to do that work. And they need tools that are complex and in-depth and cater to all of the things that are required to create actual super detailed, super essentially complex, realistic maps of geographic space. But 95% of the people who are going to use maps do not need to use maps like that. 95% of the people are like, I need to know how to get from my front door to the grocery store. So if you look at a Google map and you look at your house or the street to your house, it's not like a that you're not seeing contours in the street. It's like a little gray box and then like a white strip and then like another gray box and an arrow, like a blue line that says, go from this box to this box. So Google recognizes that 95% of the people, probably more, 99% of the people who are going to ever do anything with a map aren't going to need to do what cartographers need to do. And so they built a platform that can ingest or take information that cartographers are generating and pull it into a platform and then deliver back a meaningful and useful abstraction of geographic space via SDK and API, so that software developers can then take that representation and build anything they want for their users, all sorts of apps and experiences. So, I mean, if you think about an app today like Zillow or Uber, like Zillow and Uber are not thinking about maps. This is a solved problem for them. Like they would never go out and attempt to build their own entire mapping platform because they would obviously use Google Maps or the 3 or 4 other geographic web mapping services that are available to them. And because of that, these applications are able to focus specifically on the application layer and the delivery of value where they should, where where they're able to, like their bread and butter. So they get to focus on a logistics platform or like delivering the best experience to people looking for real estate. And so prior to this, you had to solve that problem though. So once the web mapping platforms became sort of ubiquitous, an entire category opened up. So all the apps you see on the right and thousands more every day, the location aware applications are just a given, a part of society. And that's because Google essentially made it easy for people to build applications on top of this understanding of space. So we do the same thing, but for interior space. So architects, engineers, general contractors, super important. And the information that they generate also super important. And the tools that they use to do that, whether it's Revit or CAD or whatever, super important. We need them to do that. But 99% of the people who are ever going to need information about space are not going to need that level of complexity or fidelity of information. They're going to need action of space that they can then take and build things on top of. So Archilogic as a platform ingests complex information. It delivers back a useful abstraction of space via REST API and through SDKs. And then software developers can take those representations of space and build whatever they want. And so we're starting to see an entire category of things opening up where people are starting to solve really interesting problems because they don't have to solve the space infrastructure problem. And this is, that space infrastructure problem was what I had to work on at Apple. It's what all of our clients at Case were trying to do, and ultimately what we ended up having to do at WeWork first before we could start building applications that just delivered the value we were really looking to deliver. So where the analogy kind of falls apart in an interesting way is geographic space. There are standards and there are organizations within government at every municipality that are making sure that they have accurate representations of geographic space and that they are adhering to global standards for how digitization of geographic space should happen. Now, I'm sure I have a GIS person in the room who will tell me that that's not always the case, and there's probably some edge cases, but for the most part, every county in the world has an assessor's office and they're managing, geodata that then can be ingested relatively easily into a geographic web mapping platform. Now, everybody here, assuming we're all in AEC, knows that there is quite literally no such thing as a standard across owners, operators, and tenants. Like we are struggling, Speckle exists because within AEC, we have a hard time creating a standard that works for ourselves, for us all to communicate information. But outside of AEC, like as everybody knows, when you go to a landlord and you say, give us your best representation of space, most of the time they're handing you a photocopy of a photocopy of a photocopy of this drawing that was hand drawn in the 1940s. So like what we've acknowledged at Archilogic is that meeting people, like the approach of saying, hey, people not in AEC, here's an open standard that we think you should adhere to for your space information. And that's the sort of barrier to entry to use, platforms or tools or technology. People are throwing their hands up and saying, I don't even know what BIM means. I don't know what a standard means. Like we don't even know where to start. So what we realized is that we needed to meet people where they are. So what Archilogic does then is makes building information accessible without hassle, and that empowers anybody to build apps and experiences on top of data at scale. So as I said, we take the approach of meeting people where they are. So our experience, or what we see when we're talking to, we think of the world sort of on two sides. You have owners and operators and tenants who have the space, and then you have service providers who want to do things in space. And those service providers can be physical service providers like flexible office offerings like WeWork and Notel and stuff like that. They could be technology offerings like IoT platforms or various let's say like a flex operating software that allows you to run a space as a co-working space. Or it could be a planning service, right? A planning or consultancy service where somebody has some proprietary insight about how best to do a layout or a plan for an office, and that they're looking to provide that to people with space. So owners, operators, tenants on one side, service providers on the other side. And so these are the types of things that we're hearing. On the owner, operator, tenant side, we hear people say, I have a floor plan of my space and I don't know anything about BIM or automation or software development, or really even technology. Like I'm in paper, I'm barely using, Microsoft Excel. And then on the other side, you have service providers who are like, hey, I'm super techie. We have a great idea. We have a product. I have a software development team. I don't know anything about design, architecture, engineering, construction, and specifically, I don't know how to onboard space. Like I have this great service offering. I built this really cool thing, but I need a digitized representation of space for every single customer that I ever have. And maybe I'm going to have 10,000 customers. And now I have to figure out how to onboard 10,000 floor plans, in order to make my product useful. And so this is a nightmare problem, and I don't know how to overcome it. So this is sort of what we're hearing on either side of the spectrum. So what we offer is a combination of a service offering for digitization, and then a platform that holds those digitizations and does what we described before, exposes like a meaningful and useful abstraction of those spaces via SDK and API, so people can build or do whatever they want. So the cool thing there is, whether you have one floor plan or 10 floor plans or 10,000 floor plans, we have the ability to digitize that space at we own the SLA. So rather than you building an entire internal like architecture studio where you're going to frankly bore the crap out of your architects because all you need them to do is create basic digitizations of space, like that, we can own that so that you can rely on space onboarding that can scale with your needs, as opposed to having to like figure out, take on the overhead of building that team internally. So, you pass us floor plans in PDF or some kind of static format. Again, meet people where they are. Like even if they have full Revit outfit, even if they're using CAD, that doesn't mean that there's consistency in the way things are modeled, as we all know. And so at the end of the day, even folks with Revit models are saying to us, well, can we just export a PDF and hand you the PDFs from the Revit models and then, have them digitized? And that's ultimately where we land a lot of times, because we can guarantee the apples to apples consistency on the data model side. So you pass us plans, we digitize them, we send them back to you, you can centrally manage them, and then you can access them all via SDK and API, and in a few other ways that I'll discuss. So what we do is we have this data infrastructure layer that once the space has been digitized, we house the data obviously in the cloud. Amazing infrastructure to pull that data out in a bunch of different ways. So the way I want to focus on today is really around developer tools. So we have APIs that let you embed models like on a web page. So if you wanted to visualize a model in 3D, it's as easy as embedding something like the way you'd embed a YouTube video or a Google map or something like that. We have a space API that is a REST API that understands the spatial hierarchy of all of our models, that allows you to query information in that model and also attach metadata to any entity inside of it. And I'll talk about that in just a second. And then a floor plan SDK that makes it easy for you to build applications on the web and in mobile that are interactive and that do cool and interesting things. So on top of that is this top layer, which is an application layer. So these are our native applications, our sort of UI on top of all of this stuff. It's not purely headless. And the really important thing here is we have a space viewer. This is important. Sure, you can send a link to a model so people can see it in 2D and 3D. But the really important thing is our editor. So, as you all know, there's a million places you can go on the web to draw a floor plan. That problem is not that complicated, just in terms of drawing basic plans. On the other end of the world, you kind of have like Revit and trying to manage concepts of space in Revit. So what's difficult is, can you create an experience that allows you to do everything you need to do in space, modify space, edit it, change it, lay it out, move furniture in and out, basic things like that, while preserving the semantic integrity of the data underneath it. So as you all know, if I have a room, 2 rooms, and there's a wall that divides them, and I take this wall out, these 2 rooms have unique identifiers. Something has to happen to those unique identifiers. Like when you remove that wall, it's not just a visual, like a sort of a fanciful change that you're making here. Like this is a change to the data structure. You're collapsing 2 spaces and turning it into 1 space. That 1 space now has a unique identifier, and these other 2 spaces had unique identifiers, and there has to be a reference for those somewhere. And so our editor makes all of this stuff seamless. Like we don't expose the complexity of that decision making out to the user. The user can make these changes and know that the semantic integrity of all of the information behind it is being preserved. It's also versioned so that you can move up and down through versions that preserve things like unique identifiers so that you can build applications that even understand, changes over time and can connect information to things at various states, so on and so forth. So that's a description of our platform. And the last thing I'll say specifically about our platform is what that does is it does some really cool things. So like, as I said, our data model for a space understands the hierarchy of the things inside of that space. So floor, space, asset, and the floor is uniquely identified, the space is uniquely identified, the asset's uniquely identified, and you can attach whatever metadata you want to any one of these elements. So what that means, the output of that is that one is looks. So you can take this data model and you can consume information about this model visually in 3D. And we think we have some of the best technology on the web to do that. We built it all in-house. Super proud of our engineering team. And you'll see a little bit of that here. You can check it out on our website. The next thing is connectivity. Because every one of these things is uniquely identified and exposed via API, it's super fast to create an API integration with anything else that has an API. So if you want to put it in a BI platform, I'm going to demo that actually in a second. If you wanted to do ticket management against space, you can connect it to Zendesk. If you wanted to do a design layout and then automate the procurement process, you could connect it to an invoicing system or a supply chain system or Stripe or something like that. And finally, you have queryability. So this really becomes important at scale. Like a lot of this stuff is possible within one concept of space, but within 1,000, if you have a portfolio of 1,000 spaces, being able to ask a simple question like, the example I love to give is there was think of a big box coffee shop. And at some point in time, big box coffee shops decided that they were going to put those toasters in where they would serve breakfast food. And there was like some line in the stand where you used to be able to go into a retail coffee shop and it smelled like coffee. And then the next day they put these things in and now the coffee shops smell like breakfast sandwiches. So I'm imagining that some exec somewhere is saying, oh my God, we can't have our coffee shops smelling like toaster, like breakfast sandwiches. So I want to know every single retail location we have that one has one of these toasters in it and two is less than, 2,000 square feet because we need to pull them. Well, how do you answer that question? In one version of the world, a poor junior analyst runs around with 1,100 Excel documents and tries to do this by hand and 6 weeks later gets an answer back to the exec, at which point they've already made a non-strategic decision. Or you have an API that's mapped to your entire portfolio of space that you can ask one question programmatically and get an answer in real time. And that's what our APIs enable at scale. So that was maybe a slightly long-winded description of everything we do in our platform. But what does this mean for like the people that we've been working with? What it means is that people that are not in AEC are now starting to be able to solve problems that that this simply wouldn't have been possible without involving an entire architecture team, professional resources, and they're doing it fast and they're doing it for large volumes of space. So I'm going to run you through some basic examples of some of the ways that we're seeing this. So the first example here is BI platform integration. This has long been a dream of mine. Like if you have a portfolio of space and every one of those spaces is modeled, then you should be able to connect your API to Tableau or Retool or Power BI or whatever you're using. And somebody with just a little bit of experience in a BI platform should be able to create some kind of meaningful data visualization that tells you something or does some level of analysis about that space. So we're starting to see consulting companies do things like this and be able to deliver what would have taken, at 10, 50 times more volume of analysis than they would have been able to do before without having to involve other external groups who are doing digitization and putting these types of things together. So here's an example of an actual Retool dashboard. If you're not using Retool, I highly recommend that you look into it. So what you're seeing here is here's an entire portfolio of space that we have built inside of Archilogic as just an example. Like Elisa went around and found 80 actual floor plans in New York City, passed them through our own digitization service, received them all back super fast, and now we have a test portfolio of models that we can show you guys. So here's a whole bunch of different floors, and so we're on 3 Times Square, floor 22. So you're seeing our SDK that's being instantiated in Retool. You're seeing program all of the spaces and the types of spaces with their aggregate square footage, percentage program distribution, and a couple of different metrics that are being calculated, ratios and sort of not utilization metrics, but experience metrics based on ratios between things like workspace and play space or like meeting space. So the cool thing here is I can pick any one of these models, and this will work on any model that I choose. So this is not because we've, some analyst has typed in this information. It's looking at the actual coordinates, geospatial coordinates here, or the spatial data, and it's doing calculations in real time about how much space each of these things is. So this is an example of how people in the consulting space are now able to do things that would have otherwise taken an entire team, like the one that we built, in my prior companies and stuff like that, to do simple analyses like this. So the next example we'll give is, this is an example of warehouse route path optimization. So I'm going to jump. Oh, I lost this tab. Give me 1 second. So currently there's, as I think everyone's aware, a huge boom in the instant grocery delivery space. So this is an example of solving a very interesting problem, right? Like, you've got a whole bunch of companies operating in the space, and the companies are all competing based on SLA. Like, how fast can somebody go and grab a whole bunch of things out of a shopping cart that a customer has submitted? How fast can somebody get to this warehouse, this local bespoke warehouse, shop for items, and then get it, back to the customer within X minutes? So in this world, every second that you can shave off of the time it takes to go and do some shopping, you are saving millions or hundreds of millions of dollars, or you're able to deliver on SLA. So this is an example of doing an analysis that relies on Archilogic as a platform as well. So Archilogic receives a floor plan for like a warehouse type location. That warehouse location is laid out by a team inside Archilogic's editor. And this is an example of, this is sort of an auto-generated shopping cart. So here you have an item list that represents a foreseeable shopping cart that a customer could have. So randomly assigned from a set of predetermined shopping items. And we set a few variables here, like how fast is the shopper walking, and how long does it take them to put something that they grab off the shelf or find it on the shelf and put it in the basket. And based on that, what's the total trip time based on an optimized route path? So we pick a start and an end point on the plan, and then we use a library, like a route path library, to figure out the optimal path through the space to grab these things off of shelves. And so these shelves here actually have things assigned to them. You can see this is a storage rack. This is the Archilogic asset ID. These are map coordinates. I should say this is all actually built on top of Mapbox, this particular example. I can go into that more later. And this can have a product assignment. So based on pre-assigned assignments to shelves on this plan, this is the optimized route path through this space. So you can see if I change the walk speed here, it'll change the total trip time, or if I change the delay, change the trip time as well. And I can generate a new order and see, how all of these, if I change the order, how it would change how fast a runner would be able to make it through the space. So I think the cool thing here is why this is valuable is because this makes it possible for people to do quick analysis of space that they haven't taken yet, to see if we laid out a space in a certain way, then what is the potential for this space and how well would it function? Now, if you were to think about this from a headless perspective, like this UI is cool because it tells the story, but the UI is completely unnecessary. Running this and this route path algorithm and doing like a Monticello algorithm and coming up with an average over 1,000 runs, 1,000 randomly generated runs, would give you an ability to benchmark a particular space. And so how this dovetails into an ability to do strategic assessment of space, and also to understand what the impact would be of making programmatic changes. So if you decide that having wider aisles in between these shelves is a good idea, or feel like it could be optimized, you could go and make that change in Archilogic and immediately see the impact with an application like this. So it occurs to me, I do want to disclaim quickly that these are not applications that Archilogic built. We've built them as examples, But the idea is that your software engineering team can take, can do whatever they want once they've gotten Archilogic or using Archilogic to manage space digitally. So that's another example. A third example here is the dynamically managed representation of space. So what we see regularly is that you have space. And here, I'll give a good example from my past life. Let's say that you are selling office space and you have a space that somebody comes in and says, I want an office space that's suitable for 20 employees. Well, the likelihood that a co-working space is going to have exactly an office of 20 people is very, very low. But maybe you have a 10-person and a 5-person and a 5-person and a 6-person all next to each other. So you could put everybody in adjacent offices, and collectively that becomes an office space that satisfies that requirement. So one of the difficulties is if you're a salesperson and you're trying to do this, if you don't have some kind of structured spatial representation of your floor plans, you can't really figure this out. You literally have to open up like PDFs of floor plans and go and look and figure out like where is their availability and how big is this space, and you're doing this calculation in your head. It's impossible to actually know what the possibilities would be in a portfolio. So what this is a demonstration of is I'm going to click a space, and this is actually using turf.js. So it's saying, take the space I clicked and find all of the adjacent spaces and create a new polygon and load this, which represents the aggregate of all of the spaces that are touching the space that I clicked. And so, imagine that there's metadata connected to this with office information. You could easily display back the total aggregate number of desks in that office. The point being here is that manual intervention isn't required. So the place where we see this is, let's say that you have a sensor system, and the sensors represent a certain area of the space. One version of the world is where you take a digital representation of the floor plan, if you have it, and you draw actual sensor maps, like this sensor can reach this far, so I custom draw a polygon. In this version of the world, you can dynamically generate a shape based on actual geoprocessing and say, create a polygon that is so far from this particular point as a radius or something, and then store that polygon or dynamically generate that polygon in real time and show it on the map. So this is an example of just how you can dynamically understand and use geospatial information to get out of the world of manual intervention on floor plans and when building applications. Okay, next is querying information across a portfolio of space. So this is a problem that we see regularly. I'm very excited about this. So in a similar vein, let's say that we have a company that comes to a landlord and says, hey, I have 100 people, or let's say 100 people, and I need an office space. I want about, I'm trying to do the math in my head. Let's say 500 people, and I want 100 square feet for each of them. So I want like 50,000 square feet, and I want to move in March of next year. And I'm looking to move to New York City. So if I'm a landlord and I have to figure out where I have available space and how I'm going to satisfy these requirements, again, I'm going to start pouring through Excel files, and I'm going to ask people who know about upcoming availability and stuff, and I'm going to do the best I can to deliver back some kind of PDF that says, here's available space. So with Archilogic, you're able to query across a portfolio of space in a way that includes geospatial representations of that space. So let's say that this customer says, I want all of my employees to be on one floor in one building. So with our sample data set, we would say, okay, 80 Pine Street has a total usable square footage of 50,000. And so we could fit your entire company on this one floor. And jumping ahead a bit, maybe I am willing to take any floors in the same building. They don't have to be contiguous. I can take floor 1, 7, and 14. That creates a whole bunch more options. So now this interface, this prototype we built, is giving you back all sorts of options for how you could take various floors within certain buildings and satisfy these requirements. And so the most fun one is probably, if I come and I say, I don't care where my people are, I just want them to sit somewhere in New York City. I can pick floors across any buildings, and this is going to show me results that mix and match spaces from within a bunch of different buildings. So you'll see here, this is 3 different buildings on 4 floors in 4 different suites for a total aggregate usable square footage of 50,001, which satisfies my requirement. And within each of these spaces, I can view one of the spaces and see the actual usable square footage and what square footage is building support. So we're actually looking at this space and we are setting based on space type what space types are usable and which aren't, and we're able to show this like dynamically in real time. So again, bring yourself back to like if you had to do this in Revit, if you had to model an entire portfolio, somehow get that information exposed via Forge or otherwise, and then build an application that's able to consume this and query across this much information at scale to be able to deliver this kind of answer. In my experience, it's monumental. And this is the type of thing that can be built in weeks on top of Archilogic. So I'm actually going to, just in the sake of time, skip down to vertically integrated workplace planning. So this example I think is really cool too. So the idea is like you can, if you have a service like, we work with a major furniture as a service provider in Europe. And if you, so for like companies like this, they are able to, here's a company that comes to them and says, I would like to buy your furniture to outfit my space. And they need to be able to see what their space is going to look like. So in the world of the past, this would look like a floor plan coming into a workplace planning team who is going to use Revit or AutoCAD and has to manage their library and sort of come up with a design that works in Revit or in CAD, and then export static materials that go into InDesign or something that, you're generating some kind of collateral that you're passing back to a customer. And this all is a long, sort of lead time. It would generally take 2-3 weeks to get back any kind of proposal. And then from there, if a customer decides they like what they see, there's another giant process required to actually go and make that happen. And so with Archilogic, what we're seeing is people who are coming in, replacing their use of traditional architecture software, doing workplace planning and layout in our editor, and being able to use our API and SDK to be able to deliver not just like a static deliverable, but like an experience that shows people what the potential of the space is, and do this in literally hours or days instead of weeks. Once a customer decides that this is something that they want, they're also able to then connect that representation of space that was planned in the workplace planner in editor and kick off workflows with supply chain systems and procurement systems that make it so that that furniture actually shows up for those customers in drastically less time than would have taken otherwise. So Elisa, did you want to jump in on that at all, or should I keep moving? You're muted.
Yep, keep going.
Okay. All right. Well, this is so much talking. Sorry if this is getting a bit dry, but this is the fun part, I think. So what we're going to do now is we're going to show what we're calling a space test assertion demo. So what I'm going to be doing in this demo is actually committing code. I'm going to make commits in GitHub to production code during a live demo, which is always a fantastic idea, I think, in my experience. So what the idea here is if I have a whole bunch of space, like hundreds of spaces, and I am trying to adhere to particular standards, whether those standards are design standards or they're like safety standards, and then I am told that something has changed about a standard. I need to go make a change to a standard. How do I know if making that change to the standard is going to be either possible, or what's the impact going to be on a space? So, I think about what does that look like today? That looks like opening up Revit models one by one. Maybe I have a plugin that can run some kind of analysis that can do a check. And it's essentially bespoke, or it's one at a time. I'm going to go through every single model and I'm going to push this out to, regional teams or something who control these models. And I'm going to try to get whatever information I need. I'm going to get the answer out, whether the change to the standard that's being recommended is actually going to be possible or feasible, or it's not going to like break my space, so to speak. So in the world of software development, we think this way. We write test assertions like, here's a bunch of things that should happen. And when you commit your code, they should still happen, or they should not still happen. And if something changes, then you can't push your code. And it should tell you, hey, the change that you made makes this test fail. So this is like this is what we do in software development. So the idea was like, well, why don't we think about it like this in the world of space? So what we built is a demo where using plain JavaScript, you can write test assertions against a digital representation of space that you can then run the same way you would run test assertions in software development and see them visually to know where things are passing or failing. So, I'll jump to sort of what the future could look like there after the demo. So just to give you a sense of what you're going to see us do, we're going to update a model, like an actual Archilogic model in real time, and see the results of the test assertions change, like in real time. Then we're going to update a test assertion in real time and see the results of the test assertions change. So just a quick understanding of what we're doing here. We have a set of Archilogic models in our own account that we've digitized, same one you've been seeing in these other examples. And that's sitting on our side, like in our Archilogic account, as if we're a customer. The way that you get access to those models is via the Archilogic Space API. We then have like a proxy application that was built as a test app where the test assertions are written and are stored. And then we have a client application that consumes the tests that are in the test application and consumes information about which models have passed or failed those test assertions. So there's a world where we could have skipped this test app part here, but we wanted to be able to demo the actual changing of test assertions in real time. So you're going to see us go through a process of running some GitHub actions, which is the result of keeping these things in sync. So not necessary, but we wanted to do some cool stuff here. So that's kind of why the infrastructure looks the way it does. So now we are going to go to the demo. So here is an example of an interface that does everything I just described. So what you're seeing here is, can somebody give me a thumbs up to whether they are actually able to see, like, do I need to zoom in here like this?
Yeah, you might have to zoom in a bit more too. Yeah, that's
good.
Oh,
okay.
That's too much. Yeah,
Too
that's
much.
good.
Okay. I'll
That's
do it
good.
right. All right.
I
So
think that's good.
here's a UI that we built that are, oh, hey, Aswin, nice to see you. So here's an interface we built that does everything we just described. So what you're seeing here is a collection of floor plans that we have previously modeled, as I said, is in these other examples. And you have a set of assertions. So the floor plan should include workspaces. The floor plan should include a toilet, bathroom, and restroom spaces. And we just made these up. We just wanted to do some that would be legible to everybody. So, it's not like they actually need these things. So, floor plan should include spaces greater than 1,200 square feet. We have a few that are about, density or collaboration that just demonstrates that you can use things like ratios. And then finally, a floor plan shouldn't include spaces less than 10 square feet. So for this one, the floor plan should include workspaces. Every single one of our plans here passes this condition. So here's 123 William Street, floor 4. It's highlighting in green the spaces that are workspaces, showing you why this passes. Contrast that with Nanyang Technological University, which is a really cool location and floor plan, does not have any spaces that are of the type work, and so fails this test. So another example is, let's switch this assertion to a floor plan should include toilet, bathroom, and restroom spaces. You'll now see that there are more plans that are failing. So on this plan, 1001 Fannin, you'll see that it identifies the spaces that are toilet, bathroom, restroom spaces. And on this building, Flatiron building, floor 10, there aren't any. Like, you don't see any highlighted here, so it's failing this test. And then last, I'll show, this is going to be a little interesting because its space is less than 10 square feet. So nearly everything is going to fail because nearly every plan has spaces that are less than 10 square feet. So I'll show you one that passes. So this is a very small floor plan, and I'm assuming, and it does not have any spaces less than 10 square feet. So it passes this requirement. And I intentionally picked a ridiculous value like this, 10 square feet, so that we can change it in real time. So, okay, here's test assertions, and here's things passing and failing. So I'm going to pick this Flatiron building floor 10. And what we're going to do is Elisa is going to open Archilogic's editor, and she is going to make a change to this model. And we now want this to pass this assertion. So we want this plan to include toilet, bathroom, or restroom spaces. So now I can, okay, great. You can see both our screens at the same time. So on Elisa's screen, I'll let Elisa talk through what she's doing here.
Cool. Thanks. So right now you're seeing our editor in actions in our 3D mode. So just a quick overview of our editor. You can click any spaces and you can see any information relates to the space. So all the content, all the assets that is within the space is neatly grouped under here. And you can change the function, space name, add any metadata to a space. So for this demo, we are going to go ahead and change this storage here into a restrooms. So we have a predefined list of functions that you can pick. So now this is a restroom, and obviously in a restroom, doesn't make sense to put a wood floor. So I'm going to change this to a basic tile bathroom floor. I actually think this is a pretty big size of a bathroom. So I'm actually going to make it, maybe I'll try to divide it into two. You know, always nice to have more bathroom. So let's assume that I can create a plumbing wall here. And this is basically a shaft that will allow me to run my plumbing here. And then this 2 rooms is now categorized as restroom. I'm gonna go ahead and drop some toilets from our furniture library. And also, I'll also do a sink. And go ahead and drop that in. So for the purpose of this demo, I'm gonna go ahead and just outfit 1. And you can see in 3D, if I toggle back, you can see everything is live, instantly updated. So this looks good to me for now. I am gonna go ahead and publish this. So I want to make sure I pass Aaron's test first before I continue to make it pretty.
Right. So now we're going to jump to this repository that's holding the test conditions that you were seeing there, the test assertions. So I'm going to go to actions here, and I'm just going to pick something recent. I'm going to run a set of actions that anytime you make a commit on this repo, it automatically runs these actions. So I'm going to rerun all jobs. This is going to take about 15 seconds. So I'm going to click actions here. And it's going to look at, it's going to pull all the information out of the Archilogic API across all of these models, including the model that Elisa is working on. And then it's going to run all of the tests that we are defining here in this repository. And it's going to, so here's the result of those tests. This is just giving us an output, so we know that they ran. And now they're available to the client application. So with any luck, when I refresh this, I'm going to change this assertion to floor plan should include toilet, bathroom, and restroom spaces. Here's Flatiron building floor 10. It now passes. Here's the space that Elisa just made the change to and built, and this application can see, based on the information that came out of the API, that it passes this test. And stoked that that worked in real time. So the next thing that I want to demo is the actual changing of a test assertion. So here's, I'm going to do this in real time. Here is the code. We're going to jump down into this index file, and I'm going to assume that everybody has, is some familiarity with JavaScript here. So some simple stuff is happening. These, I'm going to zoom in because I know the reality of the screen. here's a set of functions. These are essentially these are the test assertions that you're seeing showing up in that drop-down box. And so each of those assertions is defined by a function. So in this example, I'm going to jump to this find areas less than function. And I'm actually going to switch using this amazing trick that some folks at Loggersoft showed me, that if you press the period button, it sets up a web editor and lets you do all the things in real time in a web editor in GitHub. So that's amazing. So I'm going to zoom back in here and I'm going to jump to this function. So here's this find areas less than function. So it's going to grab the data out of Archilogic on a floor plan. It's going to make sure, it's going to filter out a few space types, figure out which spaces are actually usable. And then in this case, this is the line where the calculation is being done. It's comparing the area of the space in the array of spaces that it's looking at to the area that we specified when we called that function. So the function here is find areas less than, we're passing it the floor plan data from the API, and then we're saying 10, less than 10 square feet. So what I'm going to do here is I'm going to change this to less than 50, let's call it 50 square feet. So just to jump back here, I'm going to switch this to show this assertion currently. Floor plans shouldn't include spaces less than 10 square feet. So let's pick one that's passing. 3 times square, floor 25. So it doesn't have any spaces less than 10 square feet, but I do see that it has spaces that are over, let's say, or there's 65. So let's actually set, rather than 50, let's set this to 70. And so if this works correctly, then this plan should fail because these spaces are less than 70 square feet. So 3 times square, floor 25. I'm going to make this, just to run you back through this function again really quickly. It's doing this calculation as we described on this line, and then it's checking, and basically if it passes, then it pushes this nothing. If it fails, then it passes the name of the space, and then that will be read by the front end application, which will change the color of the space from red to green, depending on whether it's a passing condition or failing condition. So basically, to write any new test assertion, you just write a new function in JavaScript, and you use whatever you want, a geoprocessing library, proprietary algorithms that you've written in JavaScript, or otherwise anything you want to write a test assertion. And so I'm going to save this, and here I'm going to say changed test assertion minimum space size. That's my commit message. I'm going to hit plus here to add, and I'm going to commit here. And so as we described before, we're going to jump back to the repository, and I'm going to go to actions. And this is now running because a commit was made. The actions are running again, and I can see where they're at. The job's starting. In a second, it should go and reprocess all of these tests again, including, so now we changed an assertion though. So now it's running that assertion against every single model in the portfolio with a new condition. And now that this is complete, I'm going to jump back to the assertion app. So again, 3 times square, floor 25 is passing currently on this assertion. I'm going to refresh. And when I pick this assertion, you'll see that the assertion changed to 70 feet because I changed it in the code. Shouldn't include spaces less than 70 feet. Now, let's see, 3 times square, floor 25 is failing. And it's highlighting all of those spaces that are now failing because these spaces are less than 70 square feet. And with that, we have successfully demoed everything in real time, making a change to production code in the repository, reprocessing all of these tests, and having them show up in a front-end client application. So at this point in time, I'm going to stop sharing my screen. And what I'd like to say is, you know, having spent over 10 years attempting to solve this problem in the industry, this is really, really, really hard to do when you're trying to manage like a couple hundred or couple thousand model Revit implementation with all sorts of, you know, connections to other services and applications. So the cool thing here is if you had nothing today, no digitization, let's say that you were a landlord and you had 500 locations, you could send those 500 locations to us today. Within a week or two, between, you know, discussions and getting all those floor plans in place, we would have those all digitized. and you would be able to run these tests. And then you could hire one software developer that writes JavaScript, and you could say, hey, I want you to codify everything that's important to us in JavaScript, and I want you to control these codes. This could happen instantaneously. So I think the beautiful thing is, like, the real future potential is, imagine a world where the planning department of New York City, when they update standards, when they update code, they actually code their code. Like they write their code in JavaScript, and they store an entire set of building codes that can be posted somewhere that's publicly accessible, and then anybody can take a floor plan, get it digitized with Archilogic, and run it against New York City building code and get an answer. And not only an answer, but like highlighting, this is what's failing. So, the sky's the limit. There doesn't have to be building code. It can be experience metrics. It can say, hey, I'm, a workplace. I'm a consultancy in workplace planning or analysis. And I have a bunch of proprietary algorithms that I've developed that ensure things like, visibility, like daylight, like egress, not even egress paths, like making sure that you're close enough to power outlets, all sorts of things. And I could store these things, these algorithms, and I could run them as tests, and I could then turn around and deliver insight back to my customers in real time. And I could do it for as many floor plans as somebody passed me, all without even involving an architect if I wanted to. So, the thing that I think, the way we think about it is sort of like people outside of AEC and scale. Like, we know that you can solve these problems for one space. Sure, like everyone in this room has been solving these problems for a long time by hand. But what do you do when you have to solve it for 1,000 of them? And what do you do when you don't have the ability to build an internal infrastructure, like to solve these problems? And that's really what we're trying to address at Archilogic. Closing thoughts, Elisa?
No, you nailed it. No, it's really exciting to like share this with everyone, and understanding the problems, and yeah.
Cool. It's really weird that I can't like actually talk to other people. I'm seeing comments, so nice to see old faces. Aswin, Mateo. I feel like this is stuff that we were talking about in 2014, and it's stuff that is coming to life. And so I'm super excited. I'm really excited about what Speckle happening in AEC, and sort of what we're doing out of AEC, and like what that pass through looks like, and how innovation on the inside and innovation on the outside come together in a really synergetic way. So, again, thank you so much for inviting us to talk. We admire everything that everybody's doing. Super exciting to see all the different panels and all the sort of the directions that people are taking things and thinking about. And if you want more information, or if you're a developer, you're in tech and you're in the building industry, you can go to archilogic.com. You can sign up for an account. It's free. You'll immediately get an API token, and you can use that API token to access demo content similarly to what we're doing today. So you can build things and test things using models that we already have without paying anything. And we would love to see what you build. So if you get an account and you do something or you build something, please share it with us, post it, tweet it, whatever. And we'll work with you to make sure that we, show the world what you're working on. And we love to see these things because it helps us think through, what we want to continue to add on the product side, whether it's for the editor or it's for our APIs. So yeah, we'd love to make that collaborative. So
on that note, just a little marketing insert. We are recently launched the editor beta version on structural editing. So the demo that I just gave on editing walls and doors are in beta version. So if anybody wants access to that, reach out, and then we'll activate that to your account. So yeah.
All right. Thanks everybody. Have a good rest of your Wednesday.